Hello and welcome to yet another video, and today we're going to continue with the job lot of mainboards, and we're just going to take the very top one. Don't know what it is, but we will find out together, because we need to get through all of them anyways. So let's see, this seems to be an Intel board. I saw the LGA socket. What do we have here? This is an ASRock H510M-HDV. Interesting small little board. Small form factor. Let's get the camera a little bit closer for this small board. I can see the CMOS battery is not on here. There are no heat sinks missing, which is great. I cannot see any physical damage yet, but I would suspect on these small boards, people try to fit these into very small form factor, and then they break something. Okay, the DDR slot is kind of broken. That's not good. You can even see a contact up there. Let's see if there's anything else broken with this one, or if it's only that one RAM slot. So let me figure out what kind of processor fits into this, because I'm not sure actually what fits into H510. And I can see a single pin also in the very top that looks a little bit different than the others. So we will have to take a look at that as well. But let me first figure out what kind of processor we need for this one. So this generation is 10th and 11th Intel, and I have a G5925 here. So let's see, get you in here the correct way. And let's put our power supply onto here and see how this one will behave, what our passive power consumption will be, and if we have a reaction to the power button or not. So let's see, our passive power consumption is very high. That is not nice to see. That is 250 milliamps, which is way too much. Let's see if it has a reaction to the power button. No, we do not have a reaction to the power button. So let's see if we have our 3-volt standby line. Well, I will always use my PCIe tester for that. And it shows 3 VSB or 3-volt dual is present. So that is there. So it seems like our SIO on the backside is heating up. I can feel it with my finger. Let's have a closer look at the backside then, where the SIO is, and check for its resistance. So now under the microscope, we have our SIO right here. And then this is one of the small SIOs. So let's have a look at maybe this capacitor right here. Let's go into resistance mode. And let's probe this. This should probably be ground this side. Yup. And this side. My probes are dirty. This side now. And we seem to have high resistance. So let's check in a higher range. Still high resistance. So this is more than 2 kilo ohms. Let's see. Yep, it has really high resistance. Okay. So let's see on some of the different capacitors that we have here, if we can get a reading. But for now, I cannot see a short circuit. 168, that seems okay, because this side is ground. Yeah, 4 kilo ohms. So it seems fine, but the SIO definitely did got hot. Let's see if I can find its power supply. It might be on the other side though. So I was looking for the power supply of the SIO And I stumbled upon this. So this is pretty bad, I gotta say. We're missing quite some things here. So I can see one resistor that is still lying around here, which is this one. And we have 1, 2, 3, 4, 5, 6, maybe 7 damaged components. So yeah, that's quite a lot of components. Don't know what this is responsible for. But yeah, we should definitely take care of this first before continuing with anything else. But for this, I will have to get a board view because I will not be able to guess or figure out by a schematic of this chip what all of this is supposed to be. So let me see if I can get a board view for that. So I wasn't able to find the exact same one, because the one I found doesn't have the SIO on the back side, only on the front side, because this seems to be an M.2 version, so it's a little bit different. But this controller that we have is, I think, still the same, because the area looks like exactly the one that we need here. So let's have a closer look. We will need this component, not this one. We will need this component. 3. Oh, this is really bad. This is for reference voltage, and this is a 392k ohm resistor. This is a very special value. That is not good. You have a 169 ohm resistor, which is also bad. Oh, and I can see it varies a lot here. Ah, this is very bad. So this board view varies way too much from what we have probably here. So let me see if I can maybe find the exact board view that I need, because this one isn't, that does sadly vary in the parts that we need. So let me have a look if I can find the proper one. So I was very lucky. I actually found a board view that has exactly what we need, because there's 2 different ones. So I found multiple different sources, and they all called the board the exact same, even though they're very different. So the one that I downloaded now has the exact same name as the one that I had before, but this one doesn't have the SIO on the front like we had before. It has it on the back like we have it on our board. And I compared it very closely. And this is also not the exact one that we have, because this has 3 inductors on the top. Oh no, it is the exact one. We don't have 3 inductors, but there's place for a third one. So this is the exact same board that we have, and now we can fix it properly and be very sure about what we are putting in here, because especially for VREF circuits, for reference, it is very important to put as close as possible the exact same components in there that are supposed to be there, because stuff won't work properly if you are off of the original values when it's about reference voltages or feedback circuits. Like, you see me very often, if you like need a 10 ohm resistor or something, you can very often just put a 0 ohm in there and it won't be a problem. Or like, instead of a 1.2k, you can say either 1k put in there or something a little bit higher. That very often doesn't make any difference at all. But in this case, where we have something about reference voltage, it is very important to have the right one. So let's see. This is a 40.2k resistor. I've seen that multiple times before. This is still a 392k, which is very bad for us to find. A 169 ohm, also difficult to find. This is not fitted, so we don't need to worry about that. This one is a 0 ohm, so that will be easy as well. This is a 0 ohm, that will be easy. This is a 100 ohm. 100 ohm is also easy. This is not fitted, which makes it easier for us. This capacitor is still there. This is not fitted. This is not fitted. Yeah, so we now know what we need to know. But the big thing is I will need to see if I can get a hold of components with exactly those values. I'm pretty sure I don't have these values on hand just with new resistors. So I need to go scavenge hunting on my donor boards to see if any of those carry resistors of that value. So that will probably take quite some time. So let me have a look for that. So let's have a look again. Let's do the easy ones first that we need. And one of the easy ones is this 0 ohm one right here. So let's do that first. We go under here, and where we need the 0 ohm one is exactly right here. So let's put a 0 ohm here first. So let's do the usual. We're going to be applying flux to here. We're going to be using our solder to put some leaded solder on there, so we lower the melting point of it. So this took quite some time, but we got one resistor in. Let's see what we need next. We need a 100 ohm resistor at the bottom, and we need a 0 ohm on top of that. So let's put those on first. So we put on a 100 ohm and a 0 ohm. So right now what I usually do is I have tagged on these, and now what I do is I just reflow the area, making sure that all of these have proper contact on both sides. So all of them are properly in place now. So let's get a quick overview. We have a 0 ohm resistor here. I probably will need to change this capacitor because it's nicked. We have 100 ohms here, we have 0 ohms here. All of these are not populated. We need a 392 at the top there. We need a 168 here. And we will need to see if this resistor still has its right value. And let's see what that resistor is supposed to have. I think it was 40k, 40.0k, 02k, no, 40.2k ohm resistor. Let's check that if that is still in range of what it's supposed to be. So the area is a little bit hot still, but let's see. 40.02. That's very good. So making sure that the contact is still there. Yep, when probing here we still get the resistance. So we can leave that resistor there, which is very good. And now for the two resistors that were very hard to find. The top one is supposed to be 392k. The only one I have is 390k, and I wasn't able to find any of the out of my donor boards. But that isn't even the worst thing. The worst thing is I couldn't find a 168 ohm resistor. And what we will try, I've done this before, is put two resistors of 82 ohms onto here and see if we can do it that way. So we will need some space to fit two resistors into here. And because don't need the pads in the middle, because there's nothing nothing fitted there, we will be using some UV masking to mask this middle bit here. And with that mask off, we will have some more space to solder in components. So what I do is I grab a UV light, and it goes hard pretty quickly. Now it's solid, and we will be able to try to solder in the two resistors in here. And I gotta be honest, I really don't know what happens when the values are a little bit off of these ones, to be perfectly honest with you. But because I don't have another way of putting any resistors in there of the right value, we will be trying this out, and we will see what will happen then. So we have two 82 ohm resistors right here now. And let's see if I somehow will be able to solder these two onto here and put them in series to get as close to the value as we need. So let's see if I will manage to do that. So that went better than expected, to be honest. Let's clean up here and see at what value we ended up, because in the board view it said it's 168 ohms with a 1% tolerance. And I do not have 1% tolerance resistors, especially not of that kind. So the resistors I use are usual 5% tolerance resistors. And yeah, we have to put two of them now in series. So let's see where we ended up actually with the resistance. So to show you properly what we have done here, this is two resistors, one sitting on the side connected to the pad, one laying flat, and it's 2 times 82 ohms. And let's see where we ended up with our resistance values here. So let's see for our resistance. 164. So these resistors are pretty much spot on with their 82 ohms. I'm going to leave it like that. I don't think we're going to get better than 164. And we will see what kind of difference that will make. So the next one we're going to put in is a 392 ohm k-ohm resistor. So let's put that one also in and see if that has changed anything for us here. And there's our resistor. Let's connect it on one side. So I do not want to use hot air right now, because that will mess up the art that we have created with the two other resistors. So let's just put Flux onto here again and solder tack on the other side that we have. So now our resistor is tack on. Let's now clean up the area and check for its resistance also, where we ended up with its tolerance. So we have now fixed basically everything. The one thing that is missing that we've not fixed is this capacitor. And this capacitor might even be important, to be honest. But hot airing it now off would be very difficult with what I've done here. Let's see in the board view what this capacitor is for, what it's responsible for. So this seems to be some kind of decoupling or something like that, with 470 picofarads. Let's test if we can connect, if we have connection to the top of it. So we're in continuity mode right now, as you can hear. And let's see now. We're going to the top of the capacitor, and we have continuity. And there we also have continuity, touching the top of the capacitor. So it seems to be somehow still connected, so I'm going to run with it. And yeah, let's see if we have different reaction now when we press the power button or not. So, let's see, we've replaced a couple of resistors, and sadly not with the exact thing that they need to be. And I'm really not sure what can happen with that. Like, maybe some of the VRM is then not being driven correctly, or whatever this is responsible for. So, let's just see. Okay, we still have basically the same power consumption. And we still have no reaction to the power button. What I want to see is if this can turn on via forcing it to through the through shorting PS on the adapter. So let's try that and see what we have. So it's only 500 milliamps. So there's basically nothing really running. We have PCIe reset being stuck. So there's probably even something more wrong with this board. So I would guess that we have to fix first the issue that we don't turn on, which is we're going back onto the SIO on the back side, and we're going to check for its resistance. Let's see now. Let's go onto the board view again. The SIO has SIO v3, which connects right here on the front next to the Wi-Fi. Let's go onto there and see what resistance it has. So let's see on that big capacitor on the top right. One side is ground and the other side is our 3 volts for the SIO. And I don't get a reading, so let's go in a high range for resistance, which has about 20k ohms, and lowering right now, going around 10k ohms. Yep, around 7k ohms. That should be fine on the 3VA side. Let's look at something different that the SIO might have. So there's also 3 VSB connected to it, which comes in from here. So let's go into this component right here. And this is 10k ohms as well. So this is also fine. So I don't think our SIO actually has a problem, because all of these seemed fine. Let's check the battery voltage resistance, which we can check on the upper side of this resistor right here. The right side, I mean. Let's see. And this has high resistance as well. So the battery voltage is also not shorted. So we don't have a short circuit on our SIO. So let's see for more physical damage around the board, because there might be a missing signal for our SIO. So because we didn't have a reaction to the power button, I was going all over the board and I wasn't able to find any more knocked off components or damage on here. And then I went back. Okay, we had very high power consumption on the amp meter. So let's check for the resistances of the PCH. And one of the resistance that you have is right here on this coil in the bottom right. And you can see we have high resistance. Then I went into the board view and looked at what the PCH also has. So what we have checked was this resistance right here, VCCN auxiliary. And what we also have is 1.8 VSB for the PCH, and it's located coming from this LDO. So let's go on to the resistance check here. So it's this regulator right there, and it's, I think it's the 7th pin. And if you look at that, we have low resistance. So let's go into a lower mode. And you can see we have basically 0 ohms. And as soon, let's go into voltage mode. If we turn this on and probe this pin, you can see 0.0032 volts, and the regulator gets real hot. Like, now I can't hold my finger on it anymore, and it left an imprint. So we have a dead PCH on 1.8 volts pretty surely. So I've made a huge mistake with diagnosing this board, which was really dumb from me. And let's now, I don't have my thermal camera on me right now, sadly. Which is why we're just going to be injecting 1.8 volts, and I will be feeling with my finger if the PCH actually gets that warm. But I'm pretty sure it will be the PCH itself. So I have 1.8 amps right now, and it's drawing 1.8 volts, and it's just drawing 6 amps. But I do not feel the PCH getting warm actually at any point. So really interestingly, it's not the PCH that is getting hot, I think. Let's get loads of IPA into here. So before I had 10 amps on the current, but it sparked a lot. So let's try a little bit fewer amps. But I don't see anything particular heating up here. Like, you can see the sparks and how much is actually shorted here. But I cannot make out what is taking all of the heat. Like, as you can see, I have 10 amps now, and look at how this behaves. It's just boiling. They're doing like fusing in here. But I gotta be honest, I cannot find where my short circuit actually is. And you see the tips of my probe, my tweezers actually getting really hot. But I don't know which component is heating up. So I will need to wait until my thermal camera comes in again. My replacement, and then we can finish this repair probably. So I've got a new thermal camera, and we will try out how this will work. We got a cable attached to right there to the 1.8 volts, and we have the power supply also there. And the power supply is currently on. And let's see. If I now make a video and we get close, we can very well see right there is the cable. It goes all the way, and this is what you can see right here is the track, which is getting hot. You need to hold it at the very right place for it to focus well. And if I now increase the amperage, you can very well see the track. This is now the track coming from that controller, 1.8 controller, going all the way under the PCH right there, and then going into the PCH. And this seems to be a short that is kind of like solder balls touching, because we got a very low ohm resistance short, but nothing getting hot except of the track, like the big copper track itself getting hot leading into the PCH. But looking at the PCH itself, there's nothing really there to see. So with that, our board is sadly toast. So it is dead on 1.8 volts to the PCH. and we could see exactly it going under the PCH. And yeah, I gotta say, I don't really know how this happens. Like, I really can't tell you how it happens that the solder balls under the PCH are shorting together. Like, I would suspect that something like that can happen um when someone reflows this and makes it worse, but this did definitely not get reflown. Like, the board looks way too good for that. No sign of soldering or anything. So yeah, this sadly goes onto the dead PCH pile. Um, this Like, the interesting thing would be to take off the PCH and measure the 1.8 volts if it's actually internally of the PCH itself or if it's a solder ball under it. Like, if you would take it off and then clean all the balls on the lower side, you could measure out the PCH and see if it's the PCH itself that is actually shorted on 1.8 volts. But this is as far as we can go on this. I've wasted quite some time with trying to figure out what kind of components go here where we were searching for the resistors. And because I measured this coil right here, which is the 1.05 volts for the PCH, and it wasn't shorted, so I was like, yeah, well, we can go further than that then with the board. But I didn't measure the 1.8 volts for the PCH, which is actually the short circuit here, which makes the board not interesting for repair anymore for us. It will go to the dead PCH pile, and maybe someday, if I actually get a rework station or something like that, we will have a look at this board. But hope you learned something. Hope you enjoyed the video. Thank you very much for watching. This was Mainboard Medic. All of my tools are linked in the description. Thank you very much, and goodbye.